Sorry, students, some network issues from my side. So I'm muting all. I don't know. Some are muting themselves. Okay. Yes. I'll start in another 2 more minutes. Since I've started late by 5 minutes, so no need to worry. So I will take till 12:45. And even if possible, in the afternoon also, we'll be having a transportation engineering class, maybe from 2:50 to 3:30. Okay. I can see 20 students have joined as of now. See, from today, from whatever the classes from today is very important to ask your friends to join, because I'm going to discuss the important topics like side distance, in that mainly stopping side distance, overtaking side distance, and numerical examples related to side distance. Even in exam, they may ask any numerical examples related to side distance, and it is for sure. And they may ask examples, that is numerical examples, or analysis, that is derivation of side distance. Like it may be any stopping side distance, intermediate side distance. Okay, I will begin. So what happened? What happens here? I will be sharing the presentation, and another is notes that I have prepared in the Microsoft OneNote. So I'll be preparing I will be sharing parallelly. So don't get confused. Just try to switch from presentation to the working like deriving the equations and all. So in between, if you have not about the doubts, if you feel like I'm not able to, if there is some network issues from my side, or if you're not able to hear me, you can raise your hands. Okay, so I'll begin. So today I'm going to discuss the topic is analysis of side distance, and in that mainly stopping side distance. This all have been discussed in the previous class. Just I will go through in a minute. What all it involves. Like stopping side distance is the minimum side distance. Sorry. In between, some network issues has been coming. Don't worry, it will resolve. Yes. So moving back to. So I was discussing about the side distance, right? So here the SSD stopping side distance, I can say it as the minimum side distance available on a highway. At any spot you can take, at any spot. For example, if you're traveling on a bike or a car, so any obstruction if you see, so you'll stop and you can you can stop and you can move aside. Or if you see any opposite vehicles coming, because of the very less width of the road, for example, for a single lane road, also 3.75 meter lane road, they provide two-way traffic. So there also side distance is required. It is stopping side distance is required. So minimum side distance available on a highway at any spot having sufficient length to enable the driver who is driving the vehicle to stop a vehicle traveling at some design speed, like small v in meter per second or capital V kilometer per hour, safely without collision with any obstruction or opposite vehicles, you can say. So it mainly depends upon the feature of the roads and whatever the driver's eye above the road surface, which is constant, which is 1.2 meter, and height of the object above the road surface 0.15 meter. Okay, so coming to the criteria, so these are the main important criteria while considering the stopping sight distance. That is height of the driver's eye and height of the object. If the height of the object is less than 0.15, so then mainly the headlight sight distance comes into the picture. Moving to the factors affecting this, I have discussed yesterday. Total reaction time, that is small t, as per IRC recommendation, 2.5 seconds is considered as a total reaction time. Total reaction time is nothing but whenever you see any object, for example, whenever you see any vehicle in front of you, so you will be applying the brakes, right? So whatever the instant of observing opposite vehicle and to the instant of applying the brakes, we say it as total reaction time. Usually we consider 2.5 seconds. And later on, speed of the vehicle is also important, that is V. It may be in meter per second or kilometer per hour. So it is also important. If speed increases, I can say stopping sight distance decreases, because at more speed, if you suddenly apply the brake, you may not able to stop the vehicle immediately. So that's why, means because of 100% application of brake may not be possible at high speed. So higher speed, less stopping sight distance, lower speed, higher stopping sight distance. Efficiency of brake, again, it mainly depends upon the age of the vehicle. If the age of the vehicle is very high, then the efficiency of the brake may not be 100%. And also characteristics of the vehicle is also important. For example, as yesterday I said, like two-wheeler, four-wheeler, even in four-wheelers, heavy trucks, right? So those characteristics are also important. Like characteristics of vehicles is nothing but size, shape, and size, shape, and weight of the vehicle. Frictional resistance between the road tire, frictional resistance between the road and vehicle tire is also important, that is small f. And for different speeds, they have given the frictional resistance value also. You can consider that. And again, I can say frictional resistance, that is f, for higher speed, as the speed increases, the f value decreases. So for example, if I say 30 kmph, less than 30 kmph is 0.440 is the frictional value, small f value, frictional, small f value, that is frictional resistance between road and vehicle tire. So for 30 or less than 30 kmph speed, friction is 0.4. For 80 kmph, the friction will be 0.35. So as speed increases, friction will be less. As I already mentioned you, higher the speed, the stopping of the vehicle takes more time. Next, gradient of the road is also important, because for ascending gradient, means for ascending, for climbing any slope, what happens there, whenever you apply the blade, the application of brake is very less, I can say. But whenever while descending, the application of the brake is very difficult. Whereas for ascending, for climbing, there no need of any application of brake, right? But sometimes we require, so that the vehicle will not move, will not go back. But while descending of the vehicle, that is, I can say a slope, that is minus n%. If ascending means plus n%. Here gradient we represent it in n. So what happens for plus n%, application of brake is possible, but for minus n, that is descending, the application of brake is very difficult. Okay, so moving to the total reaction time, this I explained you: perception, induction, emotion, perception, identification, emotion, reaction, or we say it as PIV theory. Perception, intellection. P means perception, means perceiving that there is, for example, there is a deer on a road. So perception, you perceive that there is a deer on a road. And intellection, so what happens, seeing the deer, you may not go and you may not pass through that, you may stop the vehicle, that is intellection. Emotion means you may get some fear in your mind, right? And later on, volition. So these are very important. PIV, this I've already explained, you can just go through. There is nothing to read, like you can just go through this. Volition or reaction, like act to time to start event in the motion, but not actually do action. PIV theory is important. So moving back to the SSD analysis, or I can say analysis of stopping side distance, right? So here what happens, the stopping side distance is actually the sum of lag distance and braking distance. So I will be sharing the another OneNote also. Just a minute. Here is the OneNote. So hope my screen is visible, right? Anyone can reply, is my screen visible? Can you see it clearly? Anybody is there? You can mute yourself. Sorry, you can unmute yourself. So you can see my screen.
Yes, sir.
Okay.
Yes, sir.
Yes. So coming to the stopping side distance. So analysis of stopping side distance. So here I have prepared this everything because during the class by preparing it may take time. So I prepared it already. So here you can see a vehicle. So the vehicle which is moving at some design speed V, right? A design speed V. So what happens if I want to know the stopping side distance? For example, this vehicle is moving on a level. Sorry. Okay, so moving back to the stopping side distance. So as I already mentioning, for example, this is a vehicle which is moving with the design speed V, and whenever it see any obstruction on the road, on a level road, I can say on a level road. So we need to the driver need to stop the vehicle at some certain distance. So that distance we say it as stopping side distance. So how you can determine a stopping side distance? It is a summation of lag distance and braking distance, right? So these two are important. For example, lag distance, if I talk about, here you can see I have written the notes also. I will be sharing this Microsoft note with you. No need to worry. So here I've written on in a book and I've shown you. So here you can see what all has been shown here. Like you can see the lag distance here. So the lag distance is what usually what is distance? Usually what is a distance? We say it as distance is equal to, that is, distance means meter. If I want that is m. So you know what is velocity, meter per second, right? So distance is equal to v by t, right? If you do distance is equal to v by t, then I will get distance of anything. For example, a vehicle with moving a design speed of some like I can say 30 kmph, and if you want you can convert it. And for example, very less like 3 meter per second. So for that v divided by t is nothing but, so that you can write in this way, right? Just sorry. Okay. Can you hear me? Hello? Hello? Can you hear me, right? Okay. Right. So I was talking about a vehicle with moving with a design speed v. So distance is equal to v into t. So what happens? That is velocity, which is meter per second. So I was in a hurry, so I was talking something else. Meter per second into, that is time is equal to seconds. So seconds get cancels. So distance is, we'll get it in meter. So we need velocity of any vehicle and also time. So lag distance and braking distance are determined using velocity and time, right? So what is time here? T, it is the total reaction time of a driver, and what is V is the design speed of the vehicle. Okay, so here I have written again. So V is the design speed, which is in meter per second, and T is the total reaction time of a driver, which ISA recommends as 2.5 seconds, right? So coming to the conversion of V in meter per second to kilometer per hour. So if the V is given in kilometer per hour, you can use this formula 0.278 capital V into small t. See, if you're not able to remember distance, you can remember velocity. Velocity, you know, what is velocity? Distance by time. So distance is equal to velocity into time in those way. So conversion I have written here. You can just go through this here. I have written on the side. That is conversion of V in meter per second to V capital V in kilometer per hour. So like for example, distance V into T, right? So this V meter per second. So what you can do? 1 divided by 1000 whole divided by 1 divided by 60 into 60, right? 1 hour is equal to 60 minutes. So in that way, V is equal to, so that 60 into 60 goes above and 1000 comes down. That is 1 kilometer is equal to 1000 meter, right? So this complete, you can take it to the right hand side here, capital V into T. So what capital V here, it is kmph. So if you do, so small v into T, in that place you can use 5 by 18 or 0.277, or you can write as approximately as 0.278. Okay, so wherever small v into T is there, there you can use 0.278 capital V into T, or else if he has given capital V itself, then it is well and good. If he has given small v, then you can use the simple y, so it is v into T, or else if he has given capital V, you can use 0.278 into capital V into T, or else if you want to convert the capital V into small v and use it here, you can do that also. So lag distance, simple, that is velocity into time, right? So velocity, it may be in meter per second or kilometer per hour. Okay, see meter, I've written something like this, so don't get confused here. See here what happens, the meter, meter is actually a British English, and metre is American English. So I can suggest you as use this only, meter, and units is must. Please remember, units is must. So this is a lag distance. So we have done with this. So moving back to the next, I can say it as, so moving back to the braking distance. So what happens whenever a driver sees the vehicle, he will suddenly stop the vehicle by applying the brake, right? So from here, the braking distance will begin from here. So this I can write it as in this way. For example, here weight of the vehicle we will consider for braking distance, and also for applying the brakes, whatever the resistance from the opposite direction, that we say it as frictional resistance, that will also be considered. So in simple words, I can say it as braking distance. The next step in determining stopping side distance, that is addition of braking distance, we can write it as work done in stopping of a vehicle is equal to kinetic energy of the vehicle. Okay, so what is work done for stopping the vehicle? That is friction, right? Small f here, friction between the that is vehicle tire and road surface, small f, and w is required, small f, w, and L, which is the braking distance. So this completely we say it as work done in stopping of vehicle. Next, what is kinetic energy? Kinetic energy, you know this, right? Half mv square. So this is the formula. So work done on stopping of a vehicle is equal to kinetic energy of vehicle. So after that, what you can do, you know the relation between weight and mass. Since on the left hand side there is the weight of the vehicle, so you take the mass also in terms of weight. So weight is equal to mass into specific gravity g. So mass is equal to weight by specific gravity g. So that in place of mass you can write weight by specific gravity g, right? So now on both the side, left hand side and right hand side, you have weight of the vehicle. So that get cancelled. So you'll be left with F into L on the left hand side and half into small v square by g on the right hand side. So only I need braking distance L, small l. See what happens here. Here also lag distance, we can say it as L. So you can write it as in separate terms like L means lag distance, and this as LB, that is braking distance. In that way you can write. So LL plus LB gives us the stopping side distance. So I was talking about braking distance. So only keep L on the left hand side and get the formula for braking distance, which is small v square by 2gf. Don't worry, I will again go back to the presentation. There I have clearly mentioned the equations. So hope so you now know how to determine the lag distance and braking distance for determining the stopping side distance. Okay, so moving back to the presentation here. So as already mentioning, that is analysis of SSD or SSD analysis is what? The summation of lag distance and braking distance, right? So this all the same has been given, right? So the final formula of stopping side distance at a level road, what is that here? So that will be Vt, small v into T, which is a lag distance, plus small v square divided by 2gf, which is a braking distance. So addition of lag distance and braking distance will gives us the stopping side distance at level road, right? So where v is design speed in meter per second, t is the reaction time in seconds, g is the acceleration due to gravity, and the constant value is 9.81 meter per second square, and f is the coefficient of friction. So the coefficient of friction is been given in the next I'll be showing, and this is the stopping side distance in terms of capital V, that is in kilometer per hour. In kilometer per hour. So in place of small v into t, you can write 0.278 capital V into t plus v square by 254 into f. Just a minute. Yes. So this how you got. You can again go through my note. So here I have shown you. So here I have shown you again in detail. That is this one. That is right, SSD. Here the total formula is small v into t divided by small v into t plus v square by 2gf. So if I want v in kilometer per hour, that is capital V. So this I will write it as 0.278 capital V into t. Whereas this I need to convert, right? In place of small v, I will write 0.278 into capital V whole square, or else I can write it as 5 by 8, 5 by 8. And coming down, so there what I can see, 5 by 8 means 25, 5 by 8 whole square into capital V square. So 25 divided by 324 into capital V square divided by 2gf. So this, if we have to put the g value, that is 9.81 meter per second square. So when I put, so I'll get this completely in this way, right? So after that, whatever the 25 in the numerator, so that if I take it in the denominator, so I'll get 324 into 2 into 9.81 divided by 25. So that completely gives me 254. So SSD in terms of capital V, that is kilometer per hour, is 0.278 capital V into small t plus capital V square divided by 254f. That's it. So you can go through my note again for the how you got this equation actually. Okay. So moving back to the next, that is stopping side distance at slope. I hope I'm clear with this stopping side distance at a level road. That is this one, SSD V into T plus V square by 2GF, whereas V in terms of kmph means 0.278 capital V into T plus capital V square divided by 254F. So moving back to the note again. So these are some of the coefficient of frictions, right, for different speeds. Like speed in kmph he has given, he has not given in meter per second. You can refer any of the codes or anything he has given in this speed and friction relation in speed in terms of kmph only. So just remember this. So less than 30 kmph, or I can say it as from 20 to 30 kmph, the friction value is 0.4. For 40 kmph, 0.38. As I already mentioned to you, as speed increases, the friction resistance, small f, or coefficient of friction decreases. And for 50 kmph, 0.37. For 60 kmph, 0.36. And for more than 80 kmph, it is 0.35. So the range of friction, coefficient of friction is 0.4 to 0.3. 0.4 to 0.3, from 30 to 80 kmph. You can remember in this way. Because I'm mentioning this table because in some examples or numerical examples, he may not mention the coefficient of friction. If he will just mention 60 kmph and assume the data suitably, so then for 60 kmph speed, the coefficient of friction is 0.36 in that way. So that's why you have to go through this coefficient of longitudinal friction table with respect to speed. Okay, so moving back to the next, the stopping distance itself, stopping distance at slopes. So at slopes, what happens? We have to consider the gradient in percentage. So here you can see I have drawn this diagram. So this diagram, what you can see, a steep road, sorry, it looks like the steep is very high. Whatever is possible, I have drawn here. So here you can see N. So this is N% is nothing but gradient. So this N% is nothing gradient. So whenever a vehicle climbs this type of ascending gradient, so what happens? Weight of the vehicle is important, right? And also what the angle it is been making, right? So that we say it as W sine alpha and W cos alpha. So whenever I split the inclined angle into two, that is sine and cos. So W sine alpha or W cos alpha. So here what happens? Just some 100-meter has been assumed for a distance of 100-meter. If the N gradient N%, the alpha, then what will be the tan alpha? Tan alpha will be, tan alpha means what? Tan means what? Opposite by adjacent. So N divided by N% divided by 100. So that will be tan alpha. So similarly, the same will be happens with the sine alpha also. So sine alpha here, I'll just draw here so that there will be no confusion. So this is W sine alpha, right? So this is W sine alpha here. So W sine alpha. So W sine alpha. Okay. And so this is something like angle alpha. Okay. And this is the W value. So this is the W value. W value. So this is W, right? So opposite we know. For sine, what is that? Opposite by hypotenuse. For tan, opposite by adjacent. So opposite we know. So we need hypotenuse value. So what will be this hypotenuse value? So this hypotenuse value, what it happens? It is, since it is just a minute. So this W sine alpha. So I want sine alpha. So sine alpha, that is opposite by a hypotenuse. So W sine alpha. So this N. So this is climbing, right? So this is small n in percentage. So this whatever W has shown, that is a weight acting, the weight of the vehicle acting, small n. And this distance I can say it as a 100-meter, right? So this 100-meter is horizontally, but here the vehicle is climbing, that is inclinedly. So this is, if I say it as for some 100-meter, right? So hypotenuse like 100-meter. So now what you can write in place of sine alpha, that is N opposite divided by 100-meter. So that's why I have written here braking force. So whatever this black arrow I've shown, that is the braking force, or I can say it as the resistance. So that W into sine alpha. So sine alpha, that is almost equal to W into tan alpha, that is W into N divided by 100. So here what happens? Coming to the derivation, I have shown it here in the presentation. So coming to the derivation, what happens? So what is this left hand side? You already know what is this left hand side, which is work, that is the work done for stopping of the vehicle, right? That is small f, that is small f W into L, right? Small f W into L. So work done for stopping of the vehicle. So what happens here? Small f W into L plus W into sine alpha, W into sine alpha into L. So this will be added, because which is a braking force, W into sine alpha, that will be added. So that if I take L as a common, so F into W, W into N divided by 100. So N by 100 is nothing but sine alpha is nothing but N by 100. So that will be work done. That is work done for stopping of the vehicle on the left hand side is equal to WV square by 2g. So this is the kinetic energy of the vehicle, the same from the stopping side distance at level road. So if I keep only L on the left hand side, so I'll get this equation. So I can do this calculation. I don't think so it is that much. So if I take W, so from this what happens? If I take the W outside as a common here, so I'll be left with what? F, right, plus N divided by 100 here is equal to, so here again there will be W, that is W V square by 2G. So this W and this W get cancelled. So this F plus N divided by 100 will go here to the denominator. So that is 2G into F plus N divided by 100. So plus is nothing but ascending gradient. In case of descending gradient, you can write it as minus. So that's why we write stopping side distance at slopes as small v into t plus small v square divided by 2g into f plus or minus 0.01 n. Since here n was in percentage. N was in percentage. So n divided by 100, if I, that is 1 by 100 if I write, that is 0.01. 0.01. So this is the formula for stopping side distance at slopes. So this is small v. So again for capital V, what happens? For capital V, you can write it as, that is again the same. That is 254 in the denominator. Yes, here I have written in the note. Here you can see stopping side distance whenever the speed is in kilometer per hour. 0.278 capital V into T plus capital V square divided by 254. That's it. In place of 2G, you can write 254. And later on, F plus or minus 0.01 N. And these are some of the stopping side distance values for different speeds. This has been just given. See what happens in some cases on roads, if the stopping side distance has been not designed, then what happens? They will provide a signpost or a signboards limiting the speed. You may have seen most of the roads, there are some speed limits like 30 kmph, 40 kmph, right? So in that case, there they have not designed the stopping side distance along that road, but they have provided the speed limits. So, but that is just for temporary basis, but stopping side distance should be designed for any stretch of roads. So for different design speeds, you can see like for 20 kmph, that is a stopping side distance is 20 meter. For 25, 25, 30, 30, so like that, almost nearer to the, that is, now number is nearer, that's it. So as the design speed increases, stopping side distance also increases. So I have another 4 minutes. I will try to go with this simple example. Okay, so here what he is saying, calculate the minimum side distance required to avoid head-on collisions of two cars approaching from opposite directions at 90 kmph and 60 kmph. So car 1 is 90 and car 2 is 60 kmph. Assume a reaction time of 2.5 seconds, coefficient of friction as 0.7 and braking efficiency as 50% in either the case. So here what happens, coming to this, take the attendance also. So coming to this, here he has given us what are the given values here? He has given the speeds, that is capital V, that is 90 kmph for car 1 and 60 kmph for car 2. And also he has given the reaction time, that is 2.5 seconds, and coefficient of friction small f as 0.7 for either the case, he is saying. And braking efficiency 50%. So what I can say, so here ST, stopping side distance in meters, small v into t, v square by 2gf, take this formula. So since v is been given in kmph, so convert it into meter per second. So what you can do, you can multiply 18 divided by 5, or you can divide it by 3.6 to get it in meter per second, multiply it with 3.6 to get it in kmph. It is the another way. Remember, to convert kmph to meter per second divided by 3.6. Okay, so to convert meter per second to kmph, multiply 3.6. Since you are converting smaller to higher, multiply. Since you are converting higher to smaller, divide. That way you can remember. So similarly, 90 kmph in meter per second, I am getting 25 meter per second. For 60 kmph, I am getting 16.67 meter per second. So as brake efficiency is 50%, so what we can do, the friction between the vehicle tire and the road surface should be taken half. That is 0.5 into 0.7, that is 0.35. 0.35 for both the speeds. So SSD, or else you can use the this equation also, that is stopping side distance in terms of v in terms of kmph. Okay, so coming to this, the formula, that is this formula, stopping side distance in v in meter per second. So 25 into 2.5 is the reaction time. So 25 square on the denominator divided by 2 into g is 9.81 and f is 0.35. If it has been given 0.7, since 50% brake efficiency, that condition has been mentioned, so I'm taking 0.35, 50%. So stopping side distance, I'm getting 153.6 for car 1. That is stopping side distance, that is first car SD1. Whereas for second car 2, stopping side distance will be same. You can put 16.67, 2.5, 16.67 meter per second, 2 into 9.8, 0.35, 82.2 is the stopping side distance for second car. So since side distance is to avoid head-on collision, so stopping side distance of car 1 and stopping side distance of car 2 should be added. So together total it is 235.8 meters should be the stopping side distance to end the, or to control or to protect the head-on collision of two cars coming from the opposite direction. Okay, I will be continuing again with the another examples in the afternoon. Okay, thank you so much. So stopping side distance is been completed. I will be taking overtaking side distance and the other things. So doubts also I'll be taking in the afternoon session from 2:50 to 3:30. So thank you so much for taking attendance. Thank you all. Maybe